Piecewise functions are functions that are graphed in pieces. The domains are separate. Now, where you run into piecewise functions in real life is utility bills. And they charge you per kilowatt hour depending upon your usage. So maybe from 0 to 1,000 kilowatt hours, they would charge you so much per kilowatt hour. From 1,000 to 2,000 kilowatt hours, it's a different price. So that means you'd have a different function that basically would be expressed for each portion of your kilowatt hours usage. Taxes are the same way. From 0 to so many $1,000, you pay a certain percentage. Then for everything over, say, $10,000, you pay a different percentage. And that's a piecewise function. Businesses will operate on piecewise functions. So if you take a retail business, they have, like See's Candy over here. They don't sell a lot of candy right now. Of course, it would melt, too, in Arizona. But when do they sell lots of candy? Valentine's Day, Christmas, Thanksgiving, Easter. They're kind of big kind of at Halloween. But if I were to look at my profit or my revenue as See's Candy, the function that describes my revenue will be different in the summer than it is, say, from October through the end of December, right? Because I don't sell a lot in the summer, but I sell lots and lots of beginning in October through the end of December. So my world is going to be broken up into different functions that describe what my revenue is, and it's not going to be the same thing all the time. So that's why piecewise functions end up being play a more important role, like for you guys and for even the sciences, because the world isn't constant. I mean, even this carpet doesn't wear at a constant rate. It's not constant. So I look at it, and this guy is broken into 3 pieces. This is where t is less than -5. This is where t is between -5 and 5, and where t is greater than 5. So if I wanted to find f of -6, I'd look to see where does -6 live. Well, t equals -6 is with the first function, because t is less than -5, -6 is less than -5. So I say, well, what's t of -6? I would use this first function, and it would be 3. F of -5, well, this says less than -5. I want equal to -5. Well, the second function includes, because of the equal sign, -5. So if I want f of -5, it's in this second one. And that means if I want f of -5, I use the second function. Whoops. And then f of 16, well, 16 is larger than 5, so t equals 16 is the third function. So this would be the square root of 16, which would be 4. So this describes the domain of that function. So if I were See's Candy, maybe this guy would be January to Easter, right? And this guy might be Easter, and maybe for Mother's Day you might buy candy too, to May, and this guy would be May to October. So you would break essentially your sales and your revenue down to these little blocks. And if you were going to make a presentation, to your boss, what would you do? You'd say, okay, this was for this kind, these months, this was what it is. These months, this is what it is. And you have different functions that describe that. Now that's why if I want to graph a piecewise function, and I look at this guy, he is broken into 3 pieces. I have a piece that's less than -1. I have a piece that's going to be between -1 and 2, and a piece is going to be greater than or equal to 2. So that I take my handy dandy pen, the first thing I do is I take my graph paper, it's 3 pieces, and I break my graph paper into 3 pieces. The first piece is going to be less than -1. So I draw a line at -1, and that says if x is less than -1, I'm going to graph y equals 2x plus 5. And I'm going to work in multicolor here. And now it says between -1 and 2. So I'm going to break my graph paper again at x equal 2. And I'm going to graph, and this is between x is less than or greater than or equal to -1, but strictly less than 2. I'm going to graph y equals -4. And the third piece is x greater than or equal to 2. And I'm going to graph y equals -3x plus 2. In other words, it's 3 graphs on one piece of paper. And this is as though I had a piece of 3 pieces of graph paper, right? And I'm doing 3 graphs. So do you think it's going to take you time to draw them? Yeah, you're doing 3 of them, unlike doing 1. The first one I want to do, graph, is suppose x is less than -1. I'm going to graph 2x plus 5. Less than -1. I'm going to get as close to -1 as I need to. If the number is less than -1. So -0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 0, 0, 0, 0, 0, 0, 0, 0, 1. But I'm getting close to it, right? So that says, I'm going to put in -1, but it's going to be an open dot because it does not include -1, because I'm strictly less than -1. I can get as close to -1 as I like. I'm just not at -1. Now, as a short person, this is what sometimes happens to me, all the time, actually, is that I reach up to touch something or get something, and I am almost there. I can feel the electrons emanating from the object. I can't touch the object. Finger's not quite there. Right. And that's kind of where you are. You're almost at -1. You can feel -1, almost. But you can't touch -1. And so that becomes 2 times -1 plus 5, which is 3. And since it's a straight line, only need 2 points. Less than -1 is -2. 2 times -2 plus 5, -4 plus 5 is 1. So at -1, I have +3 open dot. And at -2, it's +1, and now I can draw my line. So this is y equals 2x plus 5. pain. Pain to do a piecewise graph. Just painful. And then I want x's that are greater than or equal to -1, but less than 2. So x and y equal 4. So that says for any x value I point in, y is equal to -4. So I have -1, it includes, so this is a solid dot because of the equal sign. And if x equals -1, y equals -4. And since this is going to be a horizontal line, I just need the other endpoint. If it were curved, I'd have to put more points in. So if I were dealing with x squared minus 4, I'd need to have more coordinate points. And -4. And since it's less than -4, is my dot open or closed? Solid or open? Open. Because it doesn't include 2. So at -1, I have -4, and it's a solid dot. At 2, I also have -4. It's an open dot. And so this guy is y equal -4. And last but not least, I have, I'll pick a different color here. I'll do black. X greater than or equal to 2. Solid or open at 2? Solid. So because of the equality, it's -3x plus 2. So it's a straight line, so I only need 2 points. Woohoo! So at 2, I have -3 times 2 plus 2, which is -4. And 3 is bigger than 2. -3 times 3 plus 2, which is -9 plus 2 is -7. So x equal 2, y equal -4. Well, what does that do? That fills in that open hole. And at 3, it's -7. And this is y equals -3x plus 2. That is the graph of that function.